So your videos are out there on YouTube. You guys check that link. So I do have a playlist out there for our class. And then over our 4-day weekend, we did make a short video for chapter 20, because in chapter 20 they show you some basic things about working with enemy logic. So be sure to watch that short video or go through that information in the textbook if you'd rather do it on your own. Yes, sir? You're sharing the audio. Oh, darn. What am I sharing? Something that's not what I want. What's it showing you? It should be. Is that right? Huh. It must have just been Zoom because it looked the same to me. Being weird. Okay. We've got our project created. The first thing that we want to do is save our first scene. So we are going to use File, Save Scene As, and I'm going to go into the Scenes folder and name it _ scene _0. And our author just likes to use that naming style to make the scenes come up to the top of a list of objects or assets if we were looking at a list. We're putting them in the scene folder, so they should all kind of stay together anyway. I'll save that. Make sure we have our scene saved. Bring up my inspector window because they've got it's got that other weird one. Now, don't forget about your different screen layouts. So if you want to change the layout of your screen, remember you can use the different default ones, or you can set it up exactly the way you want it and save that.
I do have a question for you. Does yours, for some reason, I don't know why my Unity does this. I've got like a scenes folder. But it saves it in my assets, and then it gives me problems if I try to put it specifically.
Did you do File Save As? It seems like if it's your active scene, it won't let you move it or do anything with it if it's the scene that you have open. So since we're just starting, you should just be able to save a new one.
Yeah.
But I know with the Mac, it might be a little different.
So what happened is like I changed it to where in the settings folder, what is mine?
Just a little bit of difference with your map. Yeah, that one is weird. Okay, for this prototype, we're going to have our kind of castle, and we're going to be smashing the castle sort of with a, see if I can find a picture of it. I'll have to go way far. Come on, come on, come on, come on. We'll have our slingshot and our projectile that will shoot from our slingshot. This one will be kind of neat because we will have sort of an indicator on the slingshot that somebody is using it, is preparing to fire. Go to the very end and see if they show us a picture. Not really. We'll just have to figure it out. But we're going to have this sort of castle. This one's sort of a decent picture. So this is going to be our castle here with different blocks and our slingshot. And then this light is what will be our indicator that someone is aiming using that slingshot. And when they release the mouse button, the projectile will come and hit the castle and knock blocks down from the castle. So that's sort of what we're shooting for here, is we start with our creation of our assets. So this one in your book is chapter 29. So that's what I'll be looking at. So we want our slingshot to glow when the mouse is in the range of it. If the player presses the left mouse button down while the slingshot is glowing, a projectile will instantiate. As the player moves and drags the mouse around with the button held down, the projectile will follow it, but it will remain within the limits of the sphere collider, and we'll have a white line stretching from the slingshot around the projectile to make it look a little bit more like an actual slingshot. And then when the player releases their mouse button, our projectile will fire, and our goal, of course, is to knock down the castle. So let's create some art assets. The first thing we want to create is our ground. So let's use a cube. Our cube object, I'm going to rename right away to ground. And then we want to set our transform positions on it. We want it to be position 0, -10, 0. Our rotation is going to be 0, 0, 0. And then our scale is going to be 100, 1, 4. And you'll see that sort of makes like a long, almost kind of a bowling alley kind of plane there for us.
What were the scale numbers?
100, 1, and 4.
Yeah, I think so. Now we want a material for our ground. So in our assets, let's create a material. And we want to name this MAT_ground. And then we want it to be, they say, a brown albedo color. So let's find the color. Yeah. Do what? I'm just going to make it brown.
Mine's not working.
Mine either. There we go. So you can use the wheel around it to choose your colors that show in the middle square. But then once you've got the color you want showing in that square, click in there to actually set your material color. Does that make sense? So you're using the circle to pick the different colors, primary colors from your wheel, and then you can refine that with that square that's in the middle, and that's what you're using to actually set that material color. So I've got a nice ugly brown, and I will drag that onto my ground to make my ground that color. Now they want us to set that smoothness to 0 because they say the ground is not very shiny. That looks much duller. Okay, so everybody got a ground, sir? Yes, sir?
Run into a big error. I cannot make the Unity file that starts the project saying the disk is out of space.
Oh, nice. What disk is it using?
The H drive?
That's yours.
Yeah.
You're out of space.
Yeah, I'm trying to figure that out because I've gone through and removed everything. Nothing in here has anything in it. I deleted them to try to get it.
bowling alley here. Yay. It just depends on your perspective. It hasn't. Why not? What's it doing? There's lots of other computers around here if you need to use it. It's a working computer. See if it comes up with the message or anything, or I think actually, so sometimes it's called try to fix it. Anybody else having trouble with Unity giving you a hard time? Few people. Is it working yours now?
Yeah, it's been making the file on.
It's doing it.
So I can continue on so as I catch up here.
And Tyler, Anthony, will you help Tyler? His is not helping him create that project, so he's just a little bit behind us here a bit.
So we have a brown material, super analysis, and or cube.
Mm-hmm.
Okay.
That's it. Now let's take a look at our directional light. Now for our directional light, they say one of the features of directional lights is that their position doesn't matter to the scene. Only the rotation of a directional light is taken into consideration. That being the case, let's move it out of the way by setting its transform to a position of -10, 0, 0. And it doesn't, you know, like matter a whole bunch because we're just kind of getting it out of the way. 50, -30, 0, and then scale 1, 1, 1. Because we're going to be working with some different lighting. Let's save our scene then. Tyler, is it letting you get logged on?
Can you click the cube for a second so I can get that instruction out?
Sure. If Unity can be a slowpoke. Okay, while Anthony's helping him get set, let's check our camera. So click on your main camera and let's rename it to _ main camera without a space. And in our main camera, let's set our transform. We want it to be position 0, 0, -10, 0, 0, 0 for our rotation, and 1, 1, 1 for our scale. Now, yeah, we should tag it as main camera since they caught us with that one last time. After you tag it as main camera, let's do a little bit more of customization with it. We want to set clear flags to solid color instead of skybox. Choose a brighter background color to look more like a sky blue. So I'm going to choose my background. Come on, color picker. There we go. Nice sky blue for your background. And then we want to change our projection again from perspective to orthographic. And we're going to change our size, bless you, our size to 10. I want to run it. I just want to see what those changes have done. Bless you. Oh, there's our little teeny ground down here on the ground. And there's the rest of everything being all sky for us, or solid background. Can't see it?
I don't see the ground.
Down on the bottom.
Make sure your scale's set to 1 and not zoomed in. You don't see it if it's zoomed in at all.
And check your ground settings, your position, and your scale.
They're correct.
So what else could we set? Your light. That should be okay.
That's fine.
And your camera.
Camera's fine.
He's the best. Thank you, sir. Okay, so in our size setting, the author mentions that he didn't clarify the meaning of the size setting last time. We talked about how the orthographic camera was kind of like a bird's eye view, but the size is half the height of what the camera is able to see. So if you look at your game pane, let's see if they show us this better. Here's the center of our directional light at position -10. And then the size of our camera of 10 means that 10 meters distance from the camera center to the top and bottom of the game pane. So if you look at this in your textbook and kind of visualize what it's talking about with that orthographic camera, you can kind of get a little bit more meaning out of it. Okay, let's save everything and let's set up our Slingshot. So good job resolving problems as we go, because if we wait, they can get to be really hard to find. So we're going to create a Slingshot out of 3 cylinders. So first, let's create an empty game object. And our game object should be renamed Slingshot. Let's set its transform settings to 0, 0, 0, 0, 0, 0, and 1, 1, 1. Now let's create a new cylinder. And our cylinder, let's change this first one's name to base. So this will be the base of our Slingshot, and then we'll have 2 more forming the Y part of the Slingshot. So for our base, let's drag it onto our empty Slingshot game object so that it's part of that thing.
What was the transform on that?
On the what? Yeah.
What's the transform for the cylinder?
The cylinder is going to be 0, 1, 0. And then our position, our rotation, I'm sorry, is 0, 0, 0. And lastly, our size, we want it to be a little small. So it's going to be 0.5, 1, and 0.5.
Thank you.
Mm-hmm. Now we're going to make this thing not be a collider. This is going to be a weapon, not anything that's involved in our collisions. So we want to make sure that our base is selected, and that's what we're looking at in the inspector. And we want to come find this capsule collider component and remove it. So to remove it, we're going to use the little gear at the far right with the drop down and remove component.
Something that makes sense.
Mhm. Okay, so now our base is just a base. It's not going to cause us any trouble or any sort of physics issues. So let's create a material for our slingshot and create a new material. And let's call this one MAT_slingshot. So we are going to use the same thing. Now you guys could use different materials if you wanted for different parts of it. I want to find a good color for that. They suggest kind of a yellow, a light yellow. So whatever you like. My ground is a little light for it. I don't know. Something that'll show up a little bit there as compared to my ground. More greenish than yellow, but that's all right. I'll take it. I'm going to use that material then for my slingshot. Use you. Now we want to duplicate this cylinder, and so we can use a keystroke to do that. Let's do Control D or Command D if you're on a Mac. Control D. And of course we could choose Edit, Duplicate if we wanted to also. Now, whenever we duplicate like that, first of all, we're making sure that this new item is a child of Slingshot because we're duplicating an item that is a child, and it's going to use the same material, those kinds of things. So let's rename this one. This one is going to be left arm. Can't get into rename for some reason. Now for our left arm, we do want to change our transform a little bit. It's going to be position 0, 3, 1. Rotation 45, 0, 0. And then our scale is going to be 0.5, 1.414, and 0.5. We took that decimal place out and made it huge there. Yeah, it looks huge, doesn't it? It won't when we run it. Okay, so that is our left arm. Let's duplicate it. I'm going to Control D. Try that again. Didn't listen to me. There it is. In this one, we want this one to be our right arm. Now for our right arm, can't see it right now because it's in the exact same spot as the left arm. So let's change things up. For our right arm, we want to be at position 0, 3, -1. And then our rotation will be -45. And our other settings should be the same. Okay, if you've got your slingshot set then, let's select the slingshot parent container. And now we're going to add our sphere collider to this level. So we didn't want it on the particular base or each particular part of this thing. We want it on the entire slingshot container. So let's add component, physics, sphere collider. Now in our sphere collider, let's make sure that some things are set properly. For our slingshot, we're going to change its position first because it's kind of right now floating out in space. Let's make it -10, -10, and 0. And then its rotation is going to be 0, -15, and 0. And its scale will be 1, 1, 1. Now the other things that we need to change, we want to check this box that says is trigger. We want our center position to be 0, 4, 0. And our radius to equal 3. Do I?
That makes a ball around it.
Yep. So we can see where its collider area is.
So we can adjust the size of it.
Uh-huh.
I'm going like that. Would you change the radius?
3. So whenever you're looking at these collider objects, there's going to be a lot of different properties that we'll look at. But when you set something to is trigger, you're just automatically telling Unity that you want to know when a collider object or another trigger object passes through this object. So that's how we can get that on collision method to be activated in our code, because Unity says, oh, you wanted to know about that? I'm going to let you know that something has collided. Let's do a save since we just got our slingshot all set. So I want to run it and see how it's looking. We're going to add one more thing to our slingshot. Oh, it looks cool. Does you look like that? You should see your ground and your slingshot sitting there. So we're going to set this one. One of the other things that we do in this game is we're going to set up the camera to follow that projectile. So don't worry about right now that we're so far away, because as we get it going, we'll be having our camera set up to follow that object. Yes, sir.
Doesn't that camera make everything look like it's equidistant away?
Mm-hmm. Yeah. So those settings that we're doing are just kind of as we're working on it, because we will make it point of view type camera that's following that game object. What are you looking for? On the camera? 10.
And are we supposed to move the, I have to slide it to -5 to see my.
Yeah, your Z should be okay at -10.
Okay. Check your scale on the display view. Mine started zoomed in slightly. If it's zoomed in any at all, you won't be able to see it. I just want to, as in even pre-base it without typing, so I had to move back that X equals -5. What's your aspect ratio? Aspect ratio is ×1. No, aspect ratio 16:9 or what? On the camera.
Up
So
here.
when you click play. Where can you find that? Right up there where zoom is, when you click play.
It's on your game tab, on the bar of your game.
Yeah, right up here by your game tab, right underneath. There's your aspect ratio, because that would mess it up. Let's just set up a couple of things and then we'll see what's going on with it. We're really close to being done with this section. Did you find it? Awesome. Okay, so we're gonna add our launch point. This is gonna be where our projectile is gonna emanate from for our slingshot. So we wanna add this component in our game so that it's something we can refer to in our code. So it's really not something that is meaningful though, as far as looking at it. So let's right click our slingshot and create empty. Try to see some different ways that we can do some things. So this is going to be a child of our slingshot. It's going to be our launch point. So let's name it that. Launch point. Now let's set our transform here for our launch point. Sorry, it's another one of those days where my watch is going crazy. So what we want, stop it. What we want is something that the textbook won't let me see. It says take our survey. No. I want position 040, rotation 015, 0, and scale 111. Now the 15-degree Y rotation causes our launch point to align with the XYZ axis in world coordinates. That is, it removes the negative 15-degree rotation that was added to our slingshot. They say if you choose the move tool, you can press W on your keyboard to do that. You can see the location and orientation of launch point in the scene pane. Can you see it? I can't see it. W.
You're in your game.
Ah, that would be why. There it is. So since it's an empty game object, we don't really see any traces of it on our scene. So since I have it selected, I can press the W object to activate the tools on that. Everybody see it? Is it working? Let's save.
You're in play.
Okay, good. I was like, wait, what's it doing? I see it's still playing. All right, now I can try saving. I'm glad it was dinging at me. All right, that could be one of those things where sometimes we think we have it saved and we don't. Let's create our projectile. So our projectile is just going to be a sphere. So let's add a sphere. And we want to name our sphere projectile. And for our projectile, the first thing we're going to do is add a rigid body component. So add physics rigid body. Remember, the rigid body component enables the projectile to be physically simulated, like our apples. Set our mass to 5 in your rigid body. Now let's create a new material for our projectile. So let's name it MAT_projectile. And for our projectile material, let's pick something. They say dark gray. It's up to you, but we're going to make it a little metallic. So in your metallic settings, they suggest metallic of 0.5 and a smoothness of 0.65. You can try some different ones and see what you like. Remember, all of these kinds of things that you add to your material affect your rendering speed, how long it's going to take to display components in your game, and how many refreshes will kind of occur within, or how many updates will occur within a refresh. I want to take that material then and put it on my projectile. For our projectile then, that's all we want to do right now, because we're going to instantiate these from our game in our code. So let's drag it down to our assets to create a prefab, and then we can delete the projectile from our hierarchy screen. So we don't need it to show up there. And let's save. Now we wouldn't see any differences in our scene, but we're ready to start adding some code. We've got a lot going here. So let's start with our Slingshot. These are our art assets, and bless you. Again, like we were talking about, you can use Blender, which is open source, and Blender has a lot of videos when you first start it to explain how it works, so people usually pick up on it pretty quickly. You guys also could get all of the Autodesk products for free, being OTC students who could go to Autodesk's website and register as a student, and then you could get 3D Studio Max and some of the even higher end 3D modeling tools. Yes, sir?
I did have a question
Uh-huh.
though too. I know it doesn't necessarily apply as much as in it applies with games itself. I was actually wondering, are there any kinds of tools that you can use for sound?
Yes, there are a lot. A lot of people just like Audacity, you know, and I know there are lots and lots of others, but Audacity is just a really, you know, well-used tool. I mean, people, if you have a Mac, you know, a lot of people will use GarageBand and things like that for their audio. But yeah, do you have Audacity downloaded at home? Oh, you better get Audacity if you don't have it. Yeah. Yeah, so grab it, and that's a great place. See what you can do there. I've got a bunch of albums. If you want to record them for me, have the turntable, USB. You can spend hours and hours, lose hours and hours, I can tell you. Okay, so let's start with our code for our Slingshot class. So let's create our C# script, and we want this one to be our Slingshot class. So let's name it Slingshot. And then we're going to double click to edit it in Visual Studio. Now the guys came in a week or two ago. It's been a while since we've been able to work with Unity, and they tried to update the machines to get Visual Studio and Unity talking a little bit better to each other. I don't know if it worked a bunch, but we'll see. It's working a little bit. Now, if you want the colored braces, don't forget that's easy enough. We just went to Tools, Extensions and Updates, and we searched online for VS4, and that's the tool that we downloaded to Visual Studio to add the color-coded braces. And it will make yours look a little different than mine, but it's no big deal. I mean, it's fine. VIASFORA. You can also search for color-coded curly braces and see if you can find it that way. Now remember, you will have to, you might have to close and reopen Visual Studio to let it install. Sure. I like it. Now we've got our Slingshot script here. We want to create some different methods than these ones that we have here. So let's change our start method to on mouse enter. So this method should fire whenever Unity detects that the mouse pointer has entered that area that we isolated as belonging to the Slingshot. So for the on mouse enter, for right now as we're debugging, let's just print out a message. And we'll print out a message, Slingshot on mouse enter. And of course, you don't have to make that message be in that exact format. That's just the way they wanted it to come out, where they have the Slingshot is the class name, colon, and then on mouse enter is the method name. So again, you could make yet that debugging message say anything that you wanted it to say. Now, the reason I'm changing the start and the update methods, we don't want to use those methods in this script. And if we leave them here and empty, we're still overriding the default start and update methods with ours, only we don't have any code in them. So we could actually prevent things from happening because we're overriding these methods with nothing. So we're going to change them to be these methods that we want instead. So let's create our update method. We're going to change it to be our on mouse exit method. And this method, when it fires, we want to print out a message, Slingshot on mouse exit. Let's save this. And I want to return to Unity. Now, where do you think that script should go? On the Slingshot. So now let's run and see if we've got anything. We should be able to click on our console tab to see those messages. So when mine starts, I'm going to click on my console tab to bring it up, and then I'm going to mouse over my Slingshot. Are you seeing your messages? Now I had to actually, for me, it might be because of the Zoom session, but I had to click on that Slingshot at first to get it to start giving me the messages. But once I clicked that first time, then I didn't have to click. So like I said, that was probably just because I wasn't currently on that window. Do I?
Is that on mouse, off mouse, a built-in function?
Yeah.
Yes. So it is automatically firing whenever that mouse moves in or out of that area. So whenever we put in our method, we're overriding that Unity default method to say, do this. So what could we do if we wanted to, if we thought there was something in the Unity method we wanted to run? We could do base.onMouseCenter and force that parent class to run that same method. So we don't have to do that very much with Unity, but we could if we needed to. So we've got everything set there. That looks good. So all we're doing is just doing a little troubleshooting on our side to see what's going on. So now let's add a little highlight. Let's kind of glow that Slingshot to show that it's active. To do that, let's start with our launch point. I'm going to minimize this and click on my launch point. My launch point disappeared. Yeah, my launch point disappeared. Do what? Yeah.
Mine disappeared too.
It's gone. Can you still see it?
Yeah. Did you guys make it while the game was running? No.
Maybe. I don't know. I don't think so, but I'm going to make a new one. So let's just make a new one, silly thing. It's because it's an empty game object, and yeah, we probably had it running. So let me get back up there to it. We right-clicked on Slingshot and did create empty. We named that launch point. And then we set our transform on it to be -10, -10, and 0.
No, it was 040.
Oh, I'm in there looking at the wrong one. Thank you, sir. I'm up 1. 040,
The rotation Y was 15.
15. That's the only other one. Okay, shouldn't be anything else we need to do on our launch point. Now that it's there, let's add a halo to it. So we can add these components. Let's add a component, and it's going to be an effect. And the effect we want is the halo. And it's glowing, yeah. How cool. Now let's set up some properties of our halo. First of all, the size of 5 might be a little bit big. Let's set it to 3. Can see how that changes it just a little bit. And then the color, they suggest a light gray to make sure that it's visible. Mine seems like it's a light gray already, so I'm okay with that. Okay, so our halo is going to be controlled by our Slingshot. Oh, bless you. Our Slingshot script. So let's go back to edit it some more. Now, our print statements were just debugging code. So let's go ahead and comment those out. And of course, we could come back and uncomment them if we wanted to at any time. So we thought things weren't working properly. So for our Slingshot class, let's create a class level variable. And it's public, so we'll be able to see it in the inspector. And it's a game object type variable. And we want to name it launch point. Now we're going to create a new method called awake. At the awake event, we're going to create a transform, a different type of object. And let's name it launch point trans. It's basically going to be its location and all of that information. So we want to look at the transform properties of something that we're going to find. Now I've got to make that a lowercase t there. It fixed it for me. And we want to use transform.find. And what we want to find is our launch point object in our hierarchy. So the transform is all those properties about that item. Now that we've got those saved,
Do we tag our launch point?
nope, we haven't. We're going to set up this launch point variable equal to launch point transform So when we wake up for this script, we're going to find our launch point. actually our launch point transforms, its position and all those kinds of things. We're going to save them, and then we're going to basically deactivate that launch point so that it's not showing up with its halo. Now, whenever we run the on mouse enter script, we want to activate it. So launch point dot set active. We want to be true now. And then when they leave our launch point, we want to set active back to false. So someone was really wisely mentioning that we hadn't tagged our launch point yet. This transform.find is actually going to handle things a little bit different. Its current object, transform, is going to be the slingshot. So it's actually trying to find this launch point within the slingshot object. So we shouldn't need to tag it like we've had to with those other objects that were just out there randomly. Let's see how things are working now. We should be able to see some changes. Let's save and try running it. Now, if you mouse in, you should see that halo show up. And when you move out of your object, you should see it go away. Everybody's working? Yeah, let me stop running here so I don't forget. Bring up some code.
My halo disappeared. I think I actually came from.
Gone now, all the way?
Yeah. You scroll up and show the set active. Video wait, friendly.
Yours looks awesome.
Yeah, but we got a little bit of
Null reference exception object reference not set to an instance I
and that's how we name what you name option. That's what it's looking
She usually posts
if you name your launch point, I don't know what those boxes have to be. Go to launch. It's a halo. I have to probably name the same thing. That's what no, that's just what that's the same as this bit, but it's still not there. It's later.
So the name of that
See the difference when it's located big, so when it's a big case, it's right. Like game.
Yes, like that's what you get from that, right? The reason we're getting this give me 1 second. You need public game object. You need launch point Lord gets it on the Game object. No, I don't. That's what creates. Maybe it's scroll up. There's a wide There are what it doesn't because it's something and one object you don't have to okay, start with your slingshot, reading or position. Change your state to 0. It's so hard. I was just wanting
No,
I said that I want
say you're done. Say you're done. Yeah, but until then, it's going to work in format. They keep it separate. It's 43. It's like in the
Is that yours?
Yes.
I'm never sure if it's the new
It's
version.
not like pretty close right now. It's like really on my laptop. It's more. It's not a. No, I have it. Yeah, it's not like a.
Oh, because it's not.
What did I call that?
yeah,
It's not like a based editor.
Because I can
Pretty
tell
good. You make little sections.
so I can tweak best in terms of it's like typed out word before.
This doesn't work like that.
What is it?
This works.
So like
This
if
one
I
you
type-
edit sound specifically with all those properties of sound. And then you got a little waveform and you can put it where you want it, like overlay it up and down a little bit. But it's not the same.
Yeah, and
The reason I asked for this is I am quite good at using.
oh,
This is all I kind of wanted to go. I guess I was wondering if there's easy stuff. With what many games or I just put Audacity. Audacity. Oh yeah, you can do a lot of cool stuff on music on it, but it's a much different workflow. It's oh, wait, I think I see what you mean. It's like you're making more, you're kind of making more custom.
See where his finger is? I can't see it. It all looks perfect to me. Okay, we got a lot of troubleshooting going on. That's good. Now let's see what we got going on here. We start out using the transform.find to find that launch point object that's within our slingshot. With this statement then saves all of those transition pieces of information. Its position, its rotation, its scale, all that stuff. Then we say, we want to set our launch point variable, that game object variable that we created earlier, equal to this transition game object. So it's finding that launch point, and then we're setting our lowercase launch point variable equal to that game object. Then we're setting it active. So in those 3 lines of code, that's what we have going on there. It's basically finding it, isolating it, and setting it to be active or inactive.
Quick question.
Uh-huh.
Now, on the transform, there's a difference with the upper and lower, right? Like that upper one, like the transform object, and the lower one is transform from the object being like the script is on.
Yes. So the transform lower is basically the property of the current object instead of the transform class.
Okay.
So, okay, looking really, really good. Lots of good stuff here. Now, some other things to notice. Whenever a game object has that set active set to false, not only is it not going to render on the screen, it's not going to receive any calls to functions like update or on collision enter. So the game object is not destroyed, but it's not really an active part of the game. Now, whenever you're looking at the inspector for a game object, the checkbox at the top of the inspector just to the left of the game object's name, this one up here, that checkbox indicates whether that object is active or not also. So we can set that true or false capability right there using that checkbox. So again, if we uncheck that, we're not really removing that game object from the game. We're just making it where it's not really active. Now the components, if you look at your inspector objects, like in this case, the component that gives us the halo, that halo component also has a checkbox that we could check or uncheck that is the same similar capability. So we could get rid of it if we wanted to. Okay, let's see if we can shoot a projectile before we go today. So we want to instantiate our projectile. I got all this good stuff. Okay, it's going to be in our Slingshot. Our Slingshot script is going to handle a lot here because it's kind of our big, giant game controller thing. So first of all, above our class level variables, let's put that badge that they've mentioned where we can say header, and then we can give it some information like set in inspector. Now the one that I want to show under the set in inspector is going to be a public game object. And this one is going to be our prefab for our projectile. And we want it to show up, it's weird how it does that. We want it to show up in the inspector so that we can drag and drop that projectile prefab onto it to get it all working. So that's the one that's going to show up in inspector. Now we have some other variables that are going to be set dynamically. So let's use a badge to show those. We'll put the header set dynamically. And again, this is just for your benefit looking at the inspector. So if you make a typo or something in that header, it's not going to be the end of the world. Now the first variable that we have in these dynamic variables is our launch point. Let's add a few more. We want, excuse me, a public vector3 variable. So this will be an XYZ coordinate. And this is going to be our launch position. We need a game object variable to hold our actual projectile. And then we're going to set up a Boolean variable to handle our aiming mode. Are we aiming? Are we not aiming? So yeah, don't forget anytime. I'm just looking at our textbook. And so all of this stuff is in the book. If you're looking at the Zoom videos later and you want to look at the book, do so. If there's something that you want to review, it's all in there. So we want to update now our awake method. We're going to leave these 3 lines of code in there that we have, but let's add one more. We're going to update our launch position variable, and we want to set it equal to our launch point transition, this one that we've saved, our transform, sorry. And we want to use that transform dot position because the transform has all of the other properties also, and we just want the position part. So the previous code saved that whole game object, our whole Slingshot game object. This line is just saving its position. Now let's leave our on mouse enter and on mouse exit methods alone. I'm going to label this closing curly brace here. This is the end of our awake method. And after our awake method, we're going to add a new method for on mouse down. Now our new on mouse down method means, of course, that the user has clicked on the mouse. They're holding the mouse button down, basically. So let's put some comments in here. The player has pressed the mouse button while over the slingshot. Bless you.
That'll automatically like default to the left mouse button.
It actually, I don't think it does, because I think you can check which mouse button it is, because like the left mouse button is button 0 and the right is button 1. So I think it would do the same thing for either mouse button. Let's try it. So we're going to say that when they press a mouse button, we're going to set our aiming mode Boolean to true. They're trying to aim. We've got the halo showing. They're holding their mouse button down. They're moving the position of the slingshot. So they are aiming. So we're going to go ahead and work on instantiating a projectile. We're going to use that instantiate command, and we want to instantiate one of our prefab projectile objects as a game object. We want it to start at that launch point. So we're going to take our projectile object that we just created, that we just instantiated, and we're going to update the transform properties, specifically the position, and set it equal to that position that we had just saved of where that slingshot is. One last thing, let's set it to is kinematic for now. My rigid body should be within that. Now within my projectile.get component, I want to get that rigid body, and I'm going to set the is kinematic to true.
You spelled one wrong.
How's that? That better? Now, whenever we have the code between these greater than, less than symbols like this, our author says this is called a compiler attribute, and it gives specific instructions to Unity or the compiler. Basically, anytime we have the greater than, less than brackets like this, we're looking at a data type. And for this get component command, we want to be looking at data types of rigid body. So whenever we see that greater than, less than, we're going to be some sort of specific information about what kind of thing that we're working with. Okay, let's look at it. Our other fields here, launch position stores that 3D world position of our launch point. Projectile is a reference to the new projectile instance that we are creating. And aiming mode is normally going to be false, but it's going to be set to true when we have that mouse down occurrence. So let's save all this. Sure. Now remember, if you're getting errors, you've got to set that prefab projectile to be your projectile prefab so that it can find it. What's it doing to you?
Apparently, I can't find the rigid body.
Let me put my projectile here. Get my prefab. Let's see if mine does the same thing.
My prefab's nothing.
So we should just be seeing it show up there. Okay, let's fix them.
Mine says the variable prefab projectile of Slingshot has not been set.
So look at it in Inspector. Find the prefab.
That's the map, right? Mine's on the
The one that is 90 gigs.
I'm using Visual Studio.
Nice.
That's just
Yeah, I think they're range back. That way it's good. What's that? Yeah.
We use a lower name object here. I guess capital is not on there.
Instead of like using the keyword, it's like doing this distinction that
Instead of saying game object. They were using generics down here. I wish it was that easy to actually use generics. You want to use generics, but you make a generic class and then sit there and like patch it capital T.
yeah.
Yeah, you got a new one.
And did you know that here on the end, it's like his script is lost of unity and everything that we reviewed and recreated it.
Would be in rigid bodies.
Yeah.
What is it?
Save it.
Okay. Let's try that same thing. Save that.
That's fine.
Yours even recognizes it, right? Mine's like, what's a game object? What's a rigid body?
And they'll keep adding, but you can put another one. Yeah. There's nothing stopping us from that. It's only on the clip, you know.
Oh, I have that. Right. That's right.
Oh yeah, just do that same.
I just realized these are just
Look at him go. You guys have projectiles showing up?
Yep.
All right. Let's do this.
When
when you click another one happens, but it's in the same spot.
You know when you shoot it.
Are you ready to try to shoot it? I don't think so. Let's add some stuff. Oh, we have time. We have time. Okay, so in your Slingshot script,
Guys,
come up to the very top and let's look where we have our prefab projectile game object. We want to add a new variable there with that one. So this is going to be a float. And what we're going to be tracking here is a velocity multiplier. And we're going to start out with a multiplier of 8. Now, whenever those errors pop up, you should see them go away after a second. And then you should be able to rearrange things. Something about these weird Unity badges is making it do some interesting spacing, but that's all right. Now, that was an object that we wanted under our heading set in Inspector. Bless you. We also want to add another variable down here to our variables that are set dynamically. So this one is going to go under our aiming mode. This is going to be a rigid body variable type. We're going to name it projectile rigid body. Now that's a long name, but it's really meaningful to us because we're talking about our projectile object and its rigid body component. Now we want to add just a couple of lines of code to our on mouse down code. Right now, we are setting up our aiming mode so that we can see that halo. Let's add a couple of lines at the end. They've got, okay, so hang on, make sure I'm doing this what they want. This line of code we're going to comment out because remember this comment that said we're just going to set it to that for now? Well, now is over. Now we're going to do something different. So now we're going to use our projectile rigid body variable that we just created. And we're going to say, hey, looking at that instance of the projectile that we created, named projectile, get its component part that is a rigid body. I need my open and close parentheses there because that's such meaningful syntax. Okay, so now instead of just setting our is kinematic to true, we're going to actually check to see what's going on with that rigid body component aspect of our projectile before we do anything. And then using this new variable, we're going to set our is kinematic to true. I can type K-I-N-E-M-A-T-I-C.
Inside the generic there, is it supposed to be your projectile rigid body or just rigid?
Just rigid body. Thank you, sir. And that's one of those things that would be color-coded if our Unity and Visual Studio interface was working all the way. It's pretty close. It's a lot better than it was. It's still not all the way. Okay, so those are the lines of code we added to our on mouse down method. Now let's see what other methods we have. When we first started working on this, we deleted the update method because we didn't want an empty one. Well, now we're finally ready to add some code for that. So I'm going to put it right after the awake method and just the keyword void and the method name update, no parameters, and then our method body. the first thing we want to do is check to see if our slingshot is not in aiming mode, meaning that they don't have the mouse over there by it, right? Don't do this. So if not aiming mode, we're just going to return out of this method. Let's go ahead and make a comment there. This is bad code. Bad. Because the return is bad. So we'll use it since it's in the book, but what we should have is instead, we could say if aiming mode and then have all of the code for this method included there. So we never want to use return or break because we're basically altering the flow of control of the program. And if somebody else were looking at it later, they could be way down in this update method and not even realize that we branched out of it at the beginning. So it's just one of those taste things. It gives us a bad taste in our mouth, so we like to stay away from it. Kind of like old go-to stuff. Okay, we need to do a couple of things in here before we can do any aiming. So whenever we send our projectile across the screen, realize that's going to have some math associated with it, right? Because we're going to be looking at its trajectory and how much force it has behind it, pushing it, and, you know, does it run into any obstacles and all those kinds of things. So that means next week, we're going to look at some math. Now, where are we as far as what do you need to do between this week and next week? Let's check. I'm going to save my scene. And I'm going to save my project because I don't trust it. And I'm going to make sure I do both. And I'm going to know still yet, next time I open this, I might have to reset a few things like where my projectile is in the inspector. Just a Unity fun thing. And then I should be ready to close Unity. Go ahead and push your project to GitHub if you want to be able to get to it from home. And then I want to bring up our stuff here. And if you have some questions, don't worry, we'll take a look at them. That's what I wanted to look at, what our schedule is. So for week 6 here, we are in good shape. We were going to look at chapter 26. Make sure you watch that video at home about those enemies. And then next week, we want to talk about object-oriented thinking, which we're doing anyways, no matter what. So we're in pretty good shape. And we'll be looking at our projectile stuff. We're in perfect spot, ready to instantiate our projectile. We'll keep working on that in class. Now, your Unit 2 game is due in just a few weeks. It's very quick. March 22nd. This is after spring break. So that means don't put everything on till spring break because you would like to have fun on spring break, right? Unless making your game is fun to you and that's what you want to do for spring break. It's fine. So you should already be thinking about it. What are you going to do? If you're one of our new programmers, you're probably going to do something that has to do with the apple tree again. Maybe you're going to make the apple tree be, you know, a bird dropping something or whatever you want it to be. But I would stick pretty close in that area unless you're feeling confident like you want to branch out. Our more experienced people are going to create awesomeness.
First person shooter.
First person shooter. We're ready with animations and all sorts of great stuff. Our guys in the back that wrote their first Python code yesterday, they're going to try to get caught up with Unity and see how it works. We got this. You guys have a great week. I'll see you next week. Let me know if you have any questions or problems, and we'll fix them.
So it is.